Alright guys, welcome back. In today's question, we need to determine the force coupled system at point O, which is equivalent to the two forces applied to the shaft AOB. And the second part of the question, we need to show if R is perpendicular to the moment vector or not. Before we start the question, please make sure to subscribe to the channel, comment and like, and share this content with your friends that might find this subject helpful. And let's jump in. So let's start with the first part of the question, that we need to find the an equivalent force coupled system, and for that we need to find a force that represents all the forces that we have in this system. Let's call the resultant of all these forces R, which will be the sum of all these forces. So we only have two forces in here. The 600 Newton force, which let's call it F1, and the 800 force, which will be F2. We'll see that the F1 is in YZ plane, which means there is no X component, and this will be the Z component, and this will be our F1 Y component. And we'll have the same thing for F2. It only has Z component and one Y component, so this will be the Y component, and this will be Z component. So let's find each of these two forces. So for F1, the Y component simply will be 600 times sine of 30 degrees, and it will be positive since it's in the positive direction. And for Z component, we have 600 times cosine of 30 degrees. That will be everything for the first force. Let's move on to the 800 Newton force, and for that we'll have for Y component negative sign, since we are in the opposite direction of the Y axis, and will be 800 times sine of 45 degrees, and we'll have 800 times cosine of 45 degrees for the K component. And that's pretty much all the forces that we have. And if we add all this together, we get minus 266 for Y component of R, and we'll get 1085 for the K, and the unit will be Newton. So that's the force part of the force coupled system. And let's move on to the moment about point O. We have two forces in here for finding the moment. First, we have the moment of 600 force. Let's call it, and we know so we need the distance vector first. And our distance vector, let's go with ROA. And we need to find the cross product of R and F, and our F will be F1. And the second moment will be R, this time OB, which is the distance vector for the force F2, and our force will be F2. And rest of this will be finding the determinant for each of these two moments. So let's start with the first one for F1. So if we look at ROA, we'll see for ROA we simply have the minus 80 millimeter distance that we have, which is in X. And if we divide that by 1000, we'll get minus 0.08 meter, and there is no Y and Z component. And our F is simply what we have in the previous step, which was 600 sine of 30, and K will be 600 cosine of 30. There is no Y component. That was the first part, and we'll have the same thing for ROB. This time ROB only has X component, but it will be positive since we are going from O to B. We see that we are moving on X-axis, and the distance will be 160 millimeter divided by 1000, which will be 0.16 meter. There is no J, there is no K. And again, we found the J and K component of the force, minus 800 sine of 45 for J, and K will be 800 cosine of 45. And the rest of this is finding this determinant. And for that, the first determinant we have simply for I component we have 0 minus 0, which will be 0, so no I component for the first part. For the J component we have a negative sign in here, so we have minus 0.080 times 600 cosine of 30 degrees. That would be our J, and for K we'll have minus 0.8 times 600 this time sine of 30 degrees. And that was the first determinant. The second determinant we have, again, there is no I component, so will be 0 I. For J, this time we have 16 times 800 cosine of 45 degrees. This will be our J, and for K we'll have 16 times minus 800 sine of 45 degrees K. And as we can see, there is only J and K component for moment as well. And if we find the moment, we'll get minus 48.9 J minus 114.5 K. And all we need to do for here is just we need to add the J component from first determinant to the second one, and we'll add the K component from the first determinant to the second one, and we'll get what we have in here. That was the first part of the question, so this is the couple part. But at the end of the question, if we get back to the beginning of the question, we'll see that in the second part, we need to show if the R is perpendicular to the moment that we found about point O. And for that, we need to show if the dot product of R and MO equals to 0, that shows that these two are perpendicular. And if not, that means that they're not perpendicular to each other. So what we found for R was this force that we found in here. So this will be our R, and we have the moment in here. And if we do the dot product of R and M, and for that we simply need to do Rx times X component of M plus the y component of I plus y component of plus rz moz, and this will be, and we have, so we know that there is no x component for r and mo, so we only have, we know each of them has only y and z component. And if we do that for the y component, we have minus 260 times minus 480.9 plus the y component is, we have 1085 times minus 114.5. And if we calculate this, we'll see that this is not equal to 0, which means the R is not perpendicular to MO. And that would be the final answer for this question. You guys have a good one.